All right, this is video 3 for the equilibrium chapter. So this is about heterogeneous equilibria. Okay, so there's two different types that we look at. We look at homogeneous equilibria and heterogeneous equilibria. And so just like when we're talking about solutions or mixtures, if it's homogeneous, that means all the reactants and products are in the same phase. And so phase just means like solid, liquid, or gas. All right, and heterogeneous means they're different. And if you remember in the first video when we first learned to write the equilibrium expressions, they are always made from only gases and aqueous substances. So KCs are only calculated from concentrations of gases and aqueous, not liquids and solids. Okay, and then KPs are only gases because they're the only ones that have pressure. All right. And you can think about that because a solid would be something that is 100% that substance. So it's not going to have a concentration. It's not like you're dissolving some of that solid in a liquid or dissolving some of that solid in a solid. Otherwise, you can't put them in the equilibrium reaction. When the reaction is written, we're saying that all of this is pure. So if it's not, it shouldn't interfere with the reaction because that stuff isn't going to react, if that makes any sense. Same with a liquid. A liquids in an equilibrium reaction are always going to be pure. All right, so if we're only going to be using gases for the first one, right here, and if I can, I'm going to write the Kc and the Kp because there's one on here that's different. Okay, so the Kc for this one is going to be equal to the concentration of H2 cubed over the concentration of water. And so the reason that we don't put this in there is because it's solid, and we don't put this in there because it's solid. All right, and then the Kp for the same reaction is going to be the same thing except it's pressure. So pressure of H2 cubed divided by the partial pressure of water. All right, and then number 2 is going to be the concentration of oxygen times the concentration of hydrogen squared, because these are two gases and this is a liquid, so it's not in the K. So it's going to be the same thing because they're both gases, except in pressure. All right, and guys, I don't want you to think that this stuff isn't important for equilibrium to get established. It has to be present, or you can't make hydrogen and oxygen gas. It can't come from nothing, but it doesn't affect the equilibrium. The amount that you have of that does not affect the equilibrium because it's not in the equilibrium expression. All right, so number 3 is going to be the concentration of HCl to the 4th divided by the concentration of SiCl4 times the concentration of H2 squared. All right, and the Kp would be the same thing. Because all the ones that are involved are gases. And so, like what I was saying earlier, just because this isn't in the equilibrium expression doesn't mean it's not produced. It still has to be produced. The last one is going to be a little bit different. So the Kc for this is going to be equal to 1 over, because all we have is a solid here. So there's no gases or aqueous substances to put in the numerator. So we put in a 1, because you can't put in 0, because then that would make Kc 0 for everything where there's a solid formed only or a liquid formed only, and that's not the case. That would tell us nothing about the reaction. All right, and then we're going to put chloride on the bottom and square it, and then mercury 1. All right, so that's the Kc expression for this. And then there's no Kp because there's no gases. So this is an example of when you would not be able to write a Kp expression because you don't have any gases to write a Kp expression for. All right, so what I was saying earlier is that solids don't affect equilibrium. Okay, for the reaction to actually work. So it can't just like, it's not that they're not there, they're there. They just don't affect the equilibrium. And you'll understand more what that means later. But basically that's it, guys. That's all that this video has to offer.